Hi, my name is Sean Haler, and I'm a data scientist at Elder Research. Today I'm going to walk through a solution to Advent of Code 2024, Day 3. And in it, I'm going to highlight the use of some regular expressions because regular expressions are used by data scientists almost every day. Let's go ahead and jump into the problem. Today we have strings that look like this, and the goal is to extract some substrings from them that have this form. An M, a U, and an L followed by some parentheses that contain some numbers separated by a comma. Before I get into the regular expression, what we're going to do with these particular values is pull them from the string, then multiply the two numbers together and sum up the results, and that will give you the solution for today's problem. To extract these, I'm going to use what's called a regular expression. The regular expression looks like a string. This is a regular expression that will match the highlighted strings above. I'm going to start with this one and explain it and then modify it a little bit to make it more useful for today's problem. Initially, we're just going to match the M, the U, and the L, and those parts of the regular expression are intended to match the substring exactly. Next, we have some open parens and some commas. The open parens, in order to match those exactly, you have to escape them within the regular expression. This is because a parenthesis has special meaning within the regular expression, and so if you want to indicate the actual parenthesis character, you have to escape it. And I'll get into parentheses a little bit more later. Additionally, we have commas, which are intended to match exactly. Finally, we have these digit strings, and in order to pull out digit strings, I'm going to use the /d character class. That will match any single digit between 0 and 9. When I add the plus, that will give me multiple or one or more digits between 0 and 9. And so without the plus, I wouldn't be able to match this 11, but with it, I can match the 11 and also the 5. It would also match digit strings that are 1,000 digits long, and the problem says not to do that. It says to match digit strings between lengths 1 and 3, and so I'm going to use the brackets here to indicate the length of the substring I want to capture, some strings between 1 and 3. Finally, I want to actually capture the numbers that are indicated by the /d character classes, and in order to do that, I'm going to use actual parentheses. These are capturing parentheses that will extract that number and return it to me. I'm going to use 2 of them. So when it comes across this mul2for function, it will pull out the 2 and it will pull out the 4 and return that to me as a list. Let's go ahead and jump into some code. I am using Python 3.9.12. I'm also using the logging module and the regular expression module. Shout out to my colleague Jeff, who helped me tighten up the first part of my Advent of Code solutions, where it's reading in the input. This particular string is just choosing the correct file name based on whether testing is true and then loading it. First thing I'm going to do is take my regular expression from the other slide and pass it to the compile method from the regular expression module. That will return an object that I can use later, and I'm going to name that object my regular expression 1. I'm going to start out with my solution being 0 and add to it as I find things that I need to add to it. I'm going to loop through all the lines in the input. For each line, I'm going to extract all the values that I can find, and I'm going to loop through those values. Let me go ahead and run this so you can see what vals looks like. So the first vals that I get as I go through this loop is the 2.4 that I had from the other slide. Then it's going to find the 5.5 and so on down the line. Now, the first value in the vals list is, for the first one, is 2, and I'm going to index that using the 0 because all lists are 0 based indexed. And the second value is indexed by the 1 value. I'm going to pass both those strings to the int function to turn them into integers, multiply them together, and then add that to my solution. Once I finish with all my lines, the solution should be the desired output. Now the input for this particular function, this is from the previous slide, it only has one line, so it only hits that outer loop once. The input for the actual problem looks like this, at least for me. So I have 6 lines that are long and not fun to look at. But let's go ahead and run it on that input, and I get an output of about 168 million. Moving back to part 2, we have a slightly modified input string. Again, I want to extract the same kind of substrings I pulled out from part 1, but I also want to pull out substrings that look like this don't function with the apostrophe and the parentheses, and this do function with the parentheses. So I need to pull out all of these substrings, and I'm going to do it essentially the same method as part 1, but I'm going to build my regular expression a little differently. So I'm going to start with the initial regular expression I had before, and I'm going to insert it into this larger one. I'm going to surround it by capturing parentheses first, and then this first part of the string should match my mul functions, just like in part 1. The second part of the string will match the don't, and the third part of the string will match the do on the end. Now I've concatenated these together using this pipe symbol, and that pipe within a regular expression means or. And so I'm asking it to find this substring or this substring or this substring. And when it finds one of them, it will return something. So when it finds the mul24 substring, this is what it will return. The first value that it returns is the value captured by the first set of capturing parentheses. And in that case, this begins the first set. It ends after the third, but it's still considered the first set. So anything in between there, it's going to return and put into that first slot, or the 0th slot. The second set of capturing parentheses is the digit there, and it's going to put that in the second position, or index 1. And the third set it captures is that number, and it will put it into the third position. The fourth position, the fourth set of capturing parentheses, is trying to capture this don't string, but that string does not match. And so this fourth set of capturing parentheses is going to return an empty string. And similarly with the fifth set. When I get to the don't part of the substring, it does match this, but the first 3 sets of capturing parentheses aren't able to capture anything because they do not match. And so those all return an empty string. The don't substring gets returned, and then the do substring does not get returned because it does not match. And finally, when we get to the do substring, it will output the do. All right, now getting back to the actual advent of code problem, imagine that you have a light switch and it's either on or off, and when it's on, we're going to proceed like we did in part 1. When it's off, we ignore the values that we pulled from the string. And in order to do this, whenever I encounter a don't function, I'm going to turn the light switch off. And whenever I encounter a do function, I'm going to turn the light switch on. So if my light switch starts on, I will collect this one and multiply it like I did in the first part. Then I turn the light switch off, and I'm going to ignore the next 2 substrings I get because my light switch is off. Then I'm going to turn the light switch back on, and I will capture the last one as well. So I should get a value of 48. Jumping back into the code. Again, I'm going to just pass my regular expression to the compile method, and this time call that object re2. I'm going to loop through all my lines and then loop through all the things it finds. I'm going to go ahead and run this now so you can kind of see what gets pulled out. So this is the first substring it matches, and it pulls out the 2 and the 4. The second substring it matches is the don't substring, and then so on down the line. This set of code down here just enables or disables my light switch. So I have my enabled value starts out true. When I find a don't substring, I turn it to false. When I find a do substring, I turn it to true. When I find an actual value, if my substring or if my light switch is enabled, then I will add those values to my solution like I did in part 1. Let me go ahead and run that on my actual input. And I get a value of about 97 million, which is in the realm of possible. It's always good to check your results. The first solution was 168 million. This is in the realm of roughly half of that, maybe 60% of that. I'm adding up a subset of the numbers I added up in part 1, so it makes sense that it's less than and probably about half. Okay. Well, thanks so much for listening. As I said, my name is Sean Haler, and I am a data scientist at Elder Research. At Elder Research, my colleagues and I really, really love Advent of Code, and we enjoy solving problems like we find in Advent of Code, which is why we work at Elder Research, because we end up solving problems like this for our clients on almost a daily basis. If you would like to join our team, please check out the links in the description, or you can go to our website at elderresearch.com. Thanks again for listening. I hope you found it enlightening.